Today we're going to be looking at part 1 of our review of the trigonometry unit. Before you watch this video, you may want to refresh yourself on some aspects of the unit by looking at the trigonometry notes that are included on the Google Classroom. So today we're going to be focusing on the primary trig ratios, and these we use with right triangles only. You want to make sure that your calculator is on degrees, and you should also use your calculator and do the calculations along with the examples once we get to them. We're going to start off with a right triangle, ABC, that we have on the right here, and we are going to label this triangle. And we're going to label the triangle with respect to what we call the reference angle. So in this case, I'm going to say that angle A is our reference angle. And we are going to label the different sides of the triangle with respect to the reference angle. So in every right triangle, there's a hypotenuse. It is across from our 90-degree angle, which is that little square in the corner there. So this is our hypotenuse. Now across from our reference angle, we have our opposite side. And beside our reference angle, we have our adjacent side. So now that we have labeled our triangle, we are going to write out our primary trig ratios according to how we've labeled the triangle. And this is where we break out sine, cosine, and tangent. So the sine of our reference angle A is equal to the length of the opposite side over the length of the hypotenuse. And I'm not going to write out the full word, I'm just going to use a short form there. The cos of our reference angle A is equal to the length of the adjacent side over the length of the hypotenuse. And the tangent, and we're just going to write tan, of our reference angle A is equal to the length of the opposite side over the length of the hypotenuse. And if we want to remember all of these trig ratios, we can use this little short form here. So, ka, toa. So the first one goes with sine is equal to the opposite over adjacent. Cosine of the reference angle is equal to adjacent over hypotenuse, and the tangent of the reference angle is equal to the opposite over the adjacent. So now we're actually going to write in those ratios using the lengths of the sides that we have on the triangle above. So sine of A is equal to 3 over 5. Cos of A is equal to 4 over 5, and tan of A is equal to 3 over 4. And I see that I've made an error here, so I'm just gonna have to do a quick erase. So tangent is not opposite over hypotenuse, it should be opposite over adjacent. And now TOA makes much more sense. Okay, so we have our 3 primary trig ratios, and we only use these with right triangles. And right refers to that 90-degree angle. So we have some steps to follow when we're actually trying to solve for a missing side or angle in a right triangle. And these steps we're going to go through for each example. So the first step is to label a triangle with respect to the reference angle. Second step is to choose the appropriate trig ratio that we're going to use. Step 3 is to substitute in known values. And step 4 is to solve and write a final solution rounded appropriately with units. Okay, and we'll talk about the rounding in a moment. So let's take a look at our first example here. We have a triangle and we are asked to solve for the missing or the indicated side. And I put both those words here because we are technically missing two sides. We're missing the side between uppercase F and uppercase E and the side between uppercase D and uppercase E. But our indicated side in this case is right here, okay, because we have a lowercase f. And notice how the labeling is done with the triangle here, that we have uppercase letters in each corner of the triangle, and then across from it we would label with the lowercase. So we can label along the bottom here with the lowercase d, and we can label this other side here with a lowercase e. So the first step is to label the triangle with respect to the reference angle. So the reference angle is always the angle that you're given or you're looking for. So right now we are given angle F to work with. So that means across from angle F, we have our opposite side. And then beside angle F, we have our adjacent side. And then always across from that 90-degree angle, we have our hypotenuse. So we have labeled the triangle with respect to the reference angle. The next step is to choose the appropriate trig ratio. So we want to be thinking about SOHCAHTOA. And what I like to do now is look at the information we're given and the information we are asked to find. So we are given a value for the hypotenuse, right? We're given 18 meters. We are asked to find the opposite side, right? There's our little F there. Now the adjacent side, we're not given it, we are not asked to find it. So I'm gonna just put an X through it for now. That leaves us with our hypotenuse and our opposite sides that we are working with. And so that means we are going to be using the primary trig ratio that has sine in it. We're going to be using SO because it doesn't have the adjacent, and the other two have that adjacent. So we're not using either of those other ones. So we want to start out just by writing down a formula. So we have sine of our reference angle F is equal to the opposite side over the hypotenuse. Next step, we are going to write in the information that we know. So we have sine of 35 degrees is equal to F, that's our opposite, that's what we need to find, over our hypotenuse, which is 18. So we want to get F by itself. So what we need to do is we need to do multiplication on the left-hand side. Because if you look on the right-hand side, we have division. We have F divided by 18, so we want to use opposite operations to get F by itself. So we have 18 times sine 35 is equal to F. Now comes the part where you're actually going to put numbers into your calculator, and I'm going to attach a couple of videos on how to use your calculator because everyone's calculator might work in a slightly different way. Just make sure if you're having difficulties with your calculator that you're using brackets around your different statements. So here I'm putting a bracket around sine 35. I'm showing multiplication, but I'm also showing that that chunk stays together, that sine and that 35. So if you do 18 times sine 35, you should get 10.3 is equal to F. And we're going to write it out properly where F is on the left-hand side. So we have F is equal to approximately 10.3. So I'm saying approximately because this is not an exact number. So we always want to round all lengths to one decimal place. So let's write that down. Round all lengths, and so that means all side lengths, to one decimal place. Okay, so we've found side F and we are finished. Let's go on to another example. So example 2 is another one where we're going to be solving for the missing or the indicated side, and you'll notice that there's a lot less labeling on this triangle. So our missing or indicated side is right here. We have a lowercase p, and then we have an angle right there that is 15 degrees, and we have another side that is 55 millimeters. So our first job is to label the triangle with respect to the reference angle. And here's our reference angle right here, which is 15 degrees. So across from 15, we have our opposite side. Beside 15, we have our adjacent side. And across from that 90-degree angle, we have our hypotenuse. So remember, the hypotenuse is the longest side always across from that 90-degree angle. It doesn't really relate to the position of the reference angle. So we are now going to decide which trig ratio we should use. So again, we're thinking about SOHCAHTOA. And you can see that we are not given the opposite side and we are not asked to find it. So we are just going to cross that out. We're not going to be working with that. So that means we're not working with anything that has the opposite side. So we're going to be working with the cos primary trig ratio, so CA. Now the cos of a reference angle, and I'm just going to use the letter A for angle because we don't have any letters on this triangle except for our little lowercase p there. And that is equal to the adjacent side over the hypotenuse. So now I'm going to fill in the information I know. Cos of angle 15 is equal to 55 over lowercase p. And lowercase p is what we are looking for. So we need to get lowercase p by itself. Now on the right-hand side, we have division happening because we have 55 divided by p. So that means we want to use the opposite operation on the other side to start to get p by itself. So we're going to have p times cos 15 is equal to 55. Now, this doesn't get us p by itself. We're not quite there yet. So we again need to use our opposite operations, and we want to use division again on the right-hand side. But this time we're going to be dividing by cos of 15. So lowercase p is equal to 55 divided by cos of 15. And again, you may need to use some brackets around that cos 15 when you're punching it into your calculator. It really depends on your calculator. So if we put that in, we should get the p is equal to approximately 56.9 millimeters. So remember, we're rounding to 1 decimal place and we are including the units that were given to us. Let's do another example where we are going to be solving for a missing angle. So in example 3, again, even less labels than we had before. We have 2 sides and then we have our missing angle. So this little symbol that is down there with the missing angle, this is called theta. Okay, it's a Greek letter. So it looks kind of like a little 0 with a line through it. So we need to label everything according to this reference angle. So across from the reference angle, we have our opposite side. Beside the reference angle, we have our adjacent side. And across from the 90-degree angle, we have our hypotenuse. So we've labeled our triangle. Now we're going to figure out which primary trig ratio to use. So we're going to take a look at our triangle and we're going to notice that we're given both the adjacent and the opposite side. So we're given some values for those. So we are going to be using those to help us find our angle. We're not given the hypotenuse and we're not looking for the hypotenuse, right? In this case, we are looking for an angle. So I'm going to cross that out. And that means we need to use whichever primary trig ratio has the adjacent and the opposite in it and not the hypotenuse. And that is going to be TOA. All right, so we're going to use the tan primary trig ratio. So we have tan of theta is equal to the opposite over adjacent. Okay, next step, we're going to fill in what we know. So the opposite is 14.1, and then the adjacent is 17.8. Now, depending on your calculator, again, there's some different ways that you may need to punch this into your calculator. And I'm going to write out the next step first and then talk about that briefly. So theta is going to be equal to tan to the -1, which is actually inverse tan, of 14.1 over 17.8, or divided by 17.8. So on your calculator, you're going to need to find that tan to the -1 button, and it's going to be a second function button. So on your calculator, you'll have a button that says second F, or you might have a button that says shift. And this tells you you're going to be accessing whatever's written above your actual buttons. So you'll have a tan button, and then above that you'll have tan to the -1. So on your calculator, you need to access this button here, this tan to the -1. And so on your calculator, you're going to need to press second function or shift in order to access that. Again, depending on your calculator, maybe you'll press it before or after you put in the other numbers. Okay, so if you're not sure, take a look at the calculator videos that are also included on the Google Classroom. So the answer you should get for this after you punched into your calculator is approximately 38 degrees. So here, when we're looking for angles, we are always going to round angles to a whole number with no decimals. So let's write that down. Round all angles to a whole number. Okay, and we are finished that one. Now, the last thing we're going to look at is we are going to do a word problem. And we're going to draw a diagram to go with our word problem. So we have a 9.5-foot ladder that leans against a wall and has a 64-degree angle of elevation with the ground. How far up the wall does the ladder reach? So angle of elevation, this tells us that it is someone or something looking out and up. So we're thinking of the perspective of looking out and then upwards. So here's our little eyeball looking out and then up, and then here's our angle in there. So we need to make sure that we are drawing our angle in correctly. Okay, so let's get going here. Here's our wall, and here's our ladder leaning up against the wall. And we assume that the wall is straight up and down, so perpendicular to the ground, so our ground is flat. So we can draw in a 90-degree angle right there. So I'm going to label this in, actually let's do it right now. So here's our wall, and here's our ladder leaning against the wall. And then we have our ground. So now we need to take the numbers that are actually given and label our triangle. So we are told that the ladder is 9.5 feet. Okay, so there we go, 9.5 feet. And we are told that it has a 64-degree angle of elevation with the ground. So here, this is 64 degrees. And that's because we imagine a little eyeball on the ground looking out. So out straight and flat and then up. And we are asked to find how far up the wall the ladder reaches. So I am going to use X for this part here. So how far up the wall the ladder reaches. So we've put on all of the numerical information and we've labeled with some words what is happening here in our diagram. And now we started at step one. So step one is label your triangle with respect to the reference angle. So we have our reference angle of 64 degrees. So across from that 64 degrees, we have our opposite side. Beside the 64 degrees, we have our adjacent side. And then across from the 90-degree angle, we have our hypotenuse. So we've labeled all of our sides here, and now we can choose which primary trig ratio we are going to use. So we are given the hypotenuse, and we're looking for the opposite. We're not looking for the adjacent, and we are not given the adjacent. So we are not going to be using the adjacent. So that means we are going to be using SO, which is the sine primary trig ratio. So we have sine of, I'm just going to put angle A because we don't have any letters here, but it's of our reference angle, is equal to opposite over hypotenuse. And our reference angle is 64 degrees. That is equal to x over 9.5. We need to get x by itself to find that distance up the wall that the ladder reaches, or the length. And we have x divided by 9.5, so we want to do a multiplication on the opposite side to get x by itself. And that is going to give us approximately 8.5. So remember that this is a length, so we are rounding to one decimal place, and just for proper form, I'm putting it with the x on the left-hand side. So we have x is equal to 8.5. I didn't put the units there. You can put the units here. Where you can also put the units is in your summary sentence. So you should always have a final sentence with a word problem. Therefore, the ladder reaches 8.5 feet up the wall. And that's it.